Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching Brahmastra series. And in this series today I am going to discuss most expected numericals part 2, most expected numericals part 1. I have already discussed 2 chapters were discussed, 10 questions were discussed. If you have not seen that, you can check that in the Brahmastra series playlist. Now without any delay, I want to start today's lecture. So how many questions are coming for numericals? 4 questions are coming, and you have to answer 2 questions, 2 numerical questions. So 10 marks is allotted for this numericals only, right? So we have discussed electric charges and electric field, electric potential and capacitance in our last class. So today I am going to discuss alternating current and ray optics, very important, and you can expect one question definitely from this chapter, alternating current, and mostly 90% of the chance is that another question will be from ray optics as well. So I have said that these 2 chapters combined, one question from alternating current, 1 question from ray optics. So total 3 questions I am giving you so that you can answer 2 of them, right? So you cannot do any suggestion on that. Okay sir, electric charges and field, electric static potential and capacitance, 1 question is coming from that, and you are saying that from these 2 chapters 2 questions are coming, so I will only follow these 2 chapters. There is no guarantee, there are a lot of questions. I am only doing the selective important questions which is most likely to come. In case the question paper setter decided that I will give easy question from the first 2 chapters, but I will give a difficult question from ray optics chapter, so you cannot help that. So you have to be prepared for that. That's why I am giving you 3 options. Out of these 3 options, definitely 2 questions will be answerable. That is my guarantee. Okay. Now, how many questions we are going to discuss? We have already discussed in our 10th January class. Total 10 questions were discussed. Today I am going to discuss another 10 questions. So total 20 questions. If you study these 20 questions, definitely you can answer 2 questions. Okay, not a bad deal, right? Now, let's start with the alternating current chapter. A series LCR circuit contains a pure inductor of inductance 5 Henry. So series LCR circuit, that means we have one L, we have a capacitor, and we have a resistance, right? That is the series LCR circuit. Okay, inductance is 5 Henry, capacitor of capacitance 20 microfarad, and a resistor of resistance 40 ohm. So these are all, everything is given. Now what? If the AC source is 200 volt 50 Hz, so it is connected to an AC source. Definitely we know that it is connected to an AC source of 200 volt 50 Hz, right? Now find the impedance, also find the resonant frequency of the circuit. So easy question, very easy question. So first we have to find the impedance. Impedance, we know that impedance formula is given by square root of resistance square plus XL minus XC whole square, right? This is the formula for impedance. So we have to calculate XL, capacity, inductive reactance. What is inductive reactance? Inductive reactance is 2 pi f L, right? So that is inductive reactance. So 2 pi into f, frequency here is given 50 Hz. So frequency is given, L is given 5 Henry, no millihenry, so no conversion is required. So simply you can add 5. So you will get 100, 500 pi. Okay, 500 pi is XL. What is XC? You can multiply the value of XL, that is fine. We try to do that at the last stage. XC will be 1 by 2 pi FC, right? This is XC. So XC is 1 by 2 pi into 50 into C. C is 20 microfarad. 20 microfarad means 20 into 10 to the power of minus 6 farad. You have to convert it into SI units, right? So you have to put that in SI unit. So let me do that. It will 2 pi into 50 into 20 into 10 to the power of minus 6. And what is the unit? Unit is obviously unit of resistance, right? Because it's a resistance. Reactance is type of resistance. Only thing, it works only in AC circuit, not in DC circuit. So let's do the calculation. So 10 to the power of 6 will go up, and in the bottom we will get 100 into 20 into pi. That is 10 to the power of 6 divided by 2000 pi. Okay, now what is this 2000 pi? So let me cancel 10 to the power of 6 can be written as 10 to the power of 3 into 1000, right? 10 to the power of 6 means after 1 there are 6 zeros, so I have taken only 3 zeros at a time so that I can cancel them with this term, right? So we get 10 to the power of 3 divided by 2 pi. So 10 to the power of 3 means again another 1000, that is after 1 there are 3 zeros, so divided by 2 pi, so it will be 1000. You can cancel that, that will be 500. So it will be 500 divided by pi. Okay, now you can calculate them using calculator, that is fine, no issues. So Excel we have calculated 500 pi, it will come out to be 1600 approximately. Okay, no issue, you can calculate it using calculator. Obviously you need to calculate it using calculator, otherwise the calculations will be slightly difficult. I am not doing it, I am giving it to you as a task. Complete it and mention in the comment below. We will check the answer at the end. Okay, so it will be around, because pi is 3.414, so it will come out to be approximately 1600. Okay, not 1600, 1500 something. Okay, but okay, let me make it 1500 only. Okay, and 500 divided by pi, again it will be 500 divided by 3.14, so it will be again somewhere around 150, right? Slightly more than 150. Right, so it will be, I am assuming it will be 160, whatever it is. Okay, I am not bothered too much about these values, you can calculate it using the calculator. Main thing is to know the steps. So impedance is basically R square, that is 40 whole square plus 1500 minus 160 whole square. You calculate whatever exact value, don't use my values, you calculate using your calculator exact values, because you are allowed to use calculators in your PU board exam, normal simple calculators. You can do this kind of calculations using the calculator. It is not a competitive exam. If it is a competitive exam, then the values would have been given such a way that you don't need to use a calculator, right? So this is the approximate value, whatever value you will get, you tell me in the answer. Now, if the AC source is of 200 volt, also find the resonant frequency of the circuit. That is important. What is the resonant frequency of the circuit? Resonance frequency is given by 1 by 2 pi square root of LC, right? So let's put that value, 1 by 2 pi square root of L is given by 5 Henry and C is given by 20 microfarad, 10 to the power of minus 6. Okay, now what is this? 1 by 2 pi, 5 into 20 is 100, so square root of 100, and 10 to the power of minus 6 square root is 10 to the power of minus 3. Very interesting. Now 10 to the power of minus 3 will go up and it will become 10 to the power of 3. So it will become 2 pi and square root of 100 is 10. So now what? So it will be 1000 divided by 2 pi into 10. So one of the zeros will cancel, 2 will cancel, it will be 50 divided by pi. So you can use the calculator to calculate the exact value. The exact answer will be 1412 ohm. So it will be 1412 ohm, and this will be 16 hertz. Okay, so this will be 16 hertz. So you can calculate it exactly using calculator as I mentioned, and you can find whatever is the exact answer to this question. Right now, let's move on to the next question. An AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry. So everything in this chapter is based on either LCR or LC or LR, write that. Okay. So an AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry. So again here it is only connected to an inductor. Capacitor is also there, 90 microfarad and resistance of 100 ohm. So again it is an LCR circuit. So you have to draw the diagram first, L, C and R. Okay, AC source of frequency is only given. First 50 Hz. Okay, 1 Henry is the L. C is 90 microfarad. 90 microfarad means what? 90 into 10 to the power of minus 6 farad, and resistance of 100 ohm. Okay. Does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. So first what we have to do, we have to calculate XL and XC. In this case, this is a special question. Okay, this is a different question. First we have to see, does the current lead or lags the voltage? So first we will calculate XL, then I will tell you what is the method to determine whether it will lead or lag. So XL is again same formula, 2 pi FL. Okay, so 2 pi into 50 into L is 1, that is equals to 100 pi, which is approximately equals to 314. Right now, what is XC? XC is 1 by 2 pi FC, that is 1 by 2 pi into 90 into 10 to the power of minus 6. Right, so now put the values. It will go up 10 to the power of 6 and it will become there will be an F also, sorry, my mistake, I made a mistake here. 2 pi into 50 into 90 into 10 to the power of minus 6. So this will go up directly. Now 50 into 2 pi is 100 pi, 100 into 90 into pi, or it will be 10 to the power of let me write it straight, 1 2 3 4 5 6, that is easy, right? So it will be 9000 into pi. So 9000, 1 2 3 4, so 3 zeros cancelled, so we get 1000 divided by 9 pi. Okay, so it will be somewhat, it will be approximately some 20. Okay, 20 ohm. You can calculate the exact values, I don't mind, right? Approximately 20. It will be not 20, it will be approximately around 30. Okay, 30 ohm. You can check it. But what the main point is that XC is less than that of XL. So circuit is inductive in nature. Whoever dominates, whoever is bigger. Okay, so here XL is bigger than XC. So XL will dominate the circuit. So if XL dominates, then the circuit is inductive. Circuit is said to be inductive. That means the current will lag the voltage. Current will lag the voltage. Current will lag the voltage. Right? If it was the opposite, that is XC is more than XL, after solving the entire problem, if you find that XC is more than XL, then current will lead the voltage. That means circuit is capacitive. In case of capacitive circuit, current leads the voltage. In case of inductive circuit, current lags the voltage. Right? Calculate the phase difference between the current and the voltage. So what is the phase difference? Tan phi equals to XL minus XC divided by R. This is the formula. You put the exact value. Okay, so approximately I can tell you that will be 314 minus 30 divided by 100. Okay, so whatever is the value, you can calculate that using a calculator, and the answer will be current lags, and tan inverse 2.79, so it will come out to be 2.79. So even after all this approximation, my calculation is almost same. Okay, I did a slight mistake here somewhere. Okay, that's why my answer is coming to 0.284, but that is very close, right? Very close. Even after approximation, even without using calculators, okay, my answer is very close to that of the actual answer. So tan inverse 2.79, if you use calculator, you will get this value, which is approximately 70 degrees. So in case you are not allowed to use scientific calculators and you cannot find tan inverse of this value, then you can leave your answer at this stage. That will be also considered as correct answer, because you are not given the calculator. You can use the log table if required and find the degree, but I'm not sure whether the log table will be available for physics test. But if it's not available, you can just leave the answer here, you will get the full marks. That is also one tip. Next, sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit in which R is equal to 3 ohm and C is equal to 800 microfarad. So sinusoidal voltage of RMS value, so Vrms of 200 volt is applied, of frequency is 50 Hz. What else is applied to a series RC circuit? So it is only RC, nothing else is there, of which R is equal to 3 ohm. So RC means RC means there is a R, right, and there is a C, and there is a AC source. Okay, frequency 50 Hz, applied series 3 ohm, and C is 800 microfarad. Okay, impedance of the circuit. Now how to calculate impedance? So in this case, XL is basically 0. That means impedance will be R square plus XC square. Okay, so we have to calculate XC. See, from solving two questions, you understood that to solve this question, formula is limited, equations are limited, but calculation wise maybe you need to use a calculator. The values are not super cute, right? Like unlike in electrostatics, electromagnetics, values are coming so cute that you can even without using calculator you could have solved it. But in this case, you definitely need to use calculators, right? So XC is 1 by 2 pi f C. So what is 2 pi into 100, and C is 800 microfarad, 10 to the power of minus 6. Remember these patterns, all the patterns will be of the same order. Okay, you have to calculate either XC or XL or XC XL both. So that is the one important thing about solving this kind of question. Again I made a mistake here. This is not 100, this is 50 Hz. 100 will be in the next stage, right? So 100 pi into 800. Right, now how many zeros will cancel now without doing any calculation? Tell me how many zeros will be cancelled. So 1 2 3 4 zeros are here, so 4 zeros will be cancelled. So 4 zeros cancel means we can write 10 square divided by 8 pi. Why 10 square? Because in the denominator we had 4 zeros, in the numerator we have 6 zeros. So 4 zeros are cancelled, so only 2 zeros are left. So it will be 100 divided by 8 pi, right? So it will be 50, 25, it will be 4, right? No, it's not 4, 4 2s are 8, so it will be 2. Okay, so approximately you can say that 25 divided by 3 2s are 6 point something. Okay, so approximately it will be 4 ohm, approximately 4 ohm. Okay, you can calculate it using your calculator exactly, but as I said, I will not use calculator. So Z equals to, what is the resistance? 3 square plus 4 square, so that is 9 plus 16, which is equals to square root of 25, so it will be 5. So impedance of the circuit is 5 ohm. Unit is important. Always remember that to use the unit is 5 ohm. So now let's move on. The current through the circuit. Now it is easy, right? Now what is current? Current is basically Z, we calculated 5. Current is V by Z. So V is 200 and Z is 5. So it will be what, 40 ampere, right? 40 ampere is the current through the circuit. Now what is the phase difference between current and the voltage? So this is the very interesting question. So phase difference tan phi, don't think that it will be 90 degrees. Okay, because circuit there is no inductance, that means it is only capacitance, so it will be 90 degrees. No, it would have been 90 degree if only capacitor was there. So current would have lead by 90 degrees, but here in this case current is lagging, current is leading, but there is a resistor also present, so you cannot simply treat it to be a capacitive circuit. So you have to calculate what is the formula. XC by XC we have calculated 3 ohm, right? Remember that. So XC by R, so XC is 3 and R is 5. Now this is a very special angle. Okay, this is a very special angle because you get to know the exact value. I think it is so phi will be equals to 53 degrees. Okay, so this is a special angle 3 4 5. How to do that? If you remember, there is a triangle, right angle triangle. You have learned that in your first PU. So this is 3, this is 4, this is 5. This is always true, right? And the angle opposite to the largest side, that is 4, it is 53 degrees, and angle opposite to that of the smallest side, it is XC by R. I made a mistake again here, it is not XC by Z. So XC was 4, XC was 4 and R was given as 3, right? R was given as 3. So it will be 3 by 4, 3 by 4, right? So it is 53 degrees, this is 37 degrees. So these are the complementary angles. This is one of the things I discussed in my basic mathematics class, basic mathematics for physics class. If you have missed that, you can check that out as well. Now 3 by 4 is basically your tan phi. So 3 that means perpendicular by base. So perpendicular in this case is 3 and base is 4. So perpendicular by base, so the angle should be 37 degrees, not 53 degrees, my mistake. It will be 37 degrees. Right? So this is the angle for this tan phi. Right? Let's check the answer once more. So I made a mistake. It will be 53 degrees because XC is 4, R is 3, so it will be 53 degrees. Yes, this is the answer for this question. Right, now let's move on to the next question. the resistor of 50 ohm, a pure inductor of 250 millihenry, a capacitor in series in a circuit containing AC source 220 volt 50 hertz in the circuit. Current leads the voltage by 60 degrees. Find the capacitance of the capacitor. This is also another type of problem, very interesting question. So again it is an LCR circuit. Okay, in this case L is given 250 millihenry and resistance is given 50 ohm, capacitor is not given, and the frequency is given 50 hertz. Frequency is only we need, okay, to solve this problem. Voltage is not required, okay, unless and until you are calculating the current in the circuit. Voltage is not required nowhere. Okay, so first we will calculate what is the XL. L is given, so we will calculate XL. XL is easy to calculate, 2 pi f L, right? So 2 pi f L equals to 2 pi into 50 into L. L is 250 millihenry. Now 250 millihenry in this case, milli means 10 to the power of minus 3, right? So 2 pi into 50 into 250 into 10 to the power of minus 3. Milli means 10 to the power of minus 3. Now let's see. So it will be 100 to 250 into 100, that is 2500 pi into 10 to the power of minus 3. So this plus 3 zeros, this is minus 3, so you will cancel. So the answer will be 25 pi. So it will be approximately 76, 77, right? So 25 pi approximately says 76 ohm. Okay, now the current in the circuit leads the voltage by 60 degrees. So current leads means XC must be greater than XL. If the current is leading, that means circuit is a capacitive circuit, right? So XC must be greater than XL. So what we have to do, this is, I will tell you the process, you will solve it at home because this is a special numerical session, right? So I have already solved similar questions in my regular Brahmastra classes. Here I am trying to help you to achieve the solution, right? So tan phi is equals to XC minus XL divided by R. So normally XL minus XC, but if it is known that circuit is capacitive or circuit is inductive, based on that we can change these two quantities. Now here they have mentioned that current leads means XC must be greater than XL, that's why we are adding this formula, right? Now tan phi is given as 60 degrees. Phi is given, phase difference is 60 degrees. So what is the value of tan 60? Tan 60 is root 3. Right? So XC we do not know. XL is 76 approximately and R is given 50 ohm. Okay, from here you have to calculate XC. Okay, so XC minus 76 equals to 50 root 3, or XC equals to 76 plus 50 root 3. So this is the value of XC. Now what is XC? We know that XC is nothing but 1 by 2 pi f into C, right? So 1 by 2 pi f into C. So 1 by C equals to 2 pi into 50, f is 50, right? So 76 plus 50 root 3. Okay, now C will be exactly 1 of that, whatever you have calculated, 100 pi. Use take out your calculator and solve this. Let me know the answer. Okay, 50 root 3, right? So if you solve it, I know the answer, by the way, it will come out to be approximately 20 microfarad. Okay, approximately 20 microfarad. You can check the answer if it is matching or not. Microfarad means somehow it will be there will be lot of zeros, 10 to the power of minus 6 will come, so you can calculate and it will be 10 to 20 microfarad. Now next question, a sinusoidal voltage of peak value 220 volt is applied to a series LCR circuit in which a resistance of resistor 5 ohm, a pure inductor of inductance 32 millihenry and a capacitor of capacitance 800 microfarad are connected. Again similar question, find the resonant frequency. Okay, calculate the impedance and power dissipated at resonance. Now trust me, this is an easier question than whatever how many questions we have solved. This is the easiest question of them all, and this is a question which is coming more repeatedly than other questions. That's why it is the last question of this chapter, right? So what is the resonant frequency? We know the resonance frequency formula. Okay, we don't need to draw the circuit diagram in this case. It is 2 pi square root of LC. This is the formula for resonant frequency. Now what is L? L is given by 32 millihenry. 1 by 2 pi 32 millihenry, so 32 into 10 to the power of minus 3, and capacitor of capacitance 800 microfarad, that is 10 to the power of minus 6. Okay, now calculation wise this is slightly tricky, again not super simple calculation, you have to do it. So 1 by 2 pi, what we can do, 32 into 8, right? 32 into 8, and if you see how many zeros are there, 1 2 zeros are here, and if you add them, how many zeros are there? 10 to the power of minus 9. So 10 to the power of minus 9, and there will be plus 2 zeros, right? So it will be 1 by 2 pi into 32 into 8 into 10 to the power of minus 7. Now this is a difficult calculation to do it, because 10 to the power of minus 7 you cannot directly take any square root of that. So what you have to do, you can use the calculator directly if that allows. Otherwise what you can do is 32 into 8 into 10 to the power of minus 1, and you take the 10 to the power of minus 6 outside. So 10 to the power of minus 7 is basically 10 to the power of minus 1 into 10 to the power of minus 6, right? Now if you take the square root of that, so 10 to the power of minus 1 will remain inside the square root, but 10 to the power of minus 6 will come out, and it will become 10 to the power of minus 3, right? This is one of the way that you can handle this problem. Now this will go up, so it will become 10 to the power of 3, that is 1000 divided by 2 pi into 3.2 into 8. So you can take this 10 to the power of minus 1 inside, and you can adjust it, okay, and you can calculate the exact value of the resonance. Okay, that is I am not super bothered about. It will be coming out to be 10 Hz. You can check, it will coming out to be 10 Hz, approximately 10 Hz. Okay, now what else? Now the second part of the question is that what is the impedance and power dissipated at resonance. So impedance at resonance is nothing but the resistance. Okay, this is the beauty of this problem. So impedance is very easy to calculate at resonance, because other two terms are equal and they cancel each other, right? XL equals to XC and they cancel each other. So that's why at resonance impedance is equal to resistance, which is given as 5 ohm. So at resonance impedance is 5 ohm. Now what is the power dissipated? power dissipated, you can calculate. There are two formulas, power is equal to VI, Vodafone Idea, or there is another formula, V square by R. Okay, power dissipated is peak value is 220 volt, 220 volt square divided by 5. Okay, you can calculate the exact power dissipated. That will be 4840 watt. 4840 watt. Okay, so first answer is 10 hertz, next answer is 5 ohm, and last answer is 4840 watt. Okay, now we are moving into the next chapter, ray optics. Okay, from now on problems will be slightly longer. An object is placed at a distance of 40 centimeter from a concave mirror of focal length 15 centimeter. So let's draw the diagram quickly. There is a concave mirror. Object is placed at a distance 40 centimeter. So U is basically 40 centimeter. Now you have to remember that in case of concave mirror, object distance, focal length, everything is negative. In case of concave mirror or concave lens, object distance is always negative, and for concave mirror or concave lens, focal length is also negative, right? So first case is given as U is minus 40 centimeter. So by default you have to put the signs. Okay, so this is U, right? Now the focal length is 15 centimeter. Focal length, this is focus, focal length is minus 15 centimeter. You have to be careful and put these values. Okay, if the object is displaced through a distance of 20 centimeter towards the mirror, by how much distance is the image displaced? So if you take this object and move it towards the mirror by a distance, say 20 centimeter, then by how much distance the image moved? So first case, suppose this is case number 1, image number 1, object number 1, the image may be somewhere, some place here. Say image was someplace where this is 1. Now after you take the object here, the image moved to somewhere here, say 2, right? So you have to find this distance. You have to find this distance. That is the problem. So first we will use the formula. So say first image distance was V1, the next was V2. First object distance is V1 and the second object distance is V2. Then we have to calculate using the mirror equation, that is 1 by V1 plus 1 by U equals to 1 by F, right? Or 1 by V1 is equal to 1 by U1, sorry, this is U1, 1 by F minus 1 by U1, or let me generalize it, that will help us to solve both the values quickly. So 1 by F1, U1 minus F. Okay, so V1 is basically FU1 by U1 minus F, right? So this is the formula. So first case, you put the values. F is given by 15 minus 15, U is given by minus 40, okay, U1 is minus 40 and F is minus 15, right? So now let's put the values. This to minus will cancel. Here 15 into 40 divided by minus 40 plus 15. Okay, this minus minus plus, so it will become plus. So you will get 15 into 40 divided by minus 25, right? So the answer will be 3 5s are 15, 5 5s are 25, 5 8s are 40, right? So it will be minus 24 centimeter. So first case, in the first case, the image distance is minus 24 centimeter. Okay, So first case it is minus 24 centimeter. Second case we will directly use the same formula. Only thing that we have to do is apply it for V2, right? So it is minus 24 centimeter. So image distance without the sign is basically 24 centimeter. Okay, now how can we calculate it for the second? So V2 will be equals to F U2 divided by U2 minus F, right? Same formula, only thing that we have to change is this U1 with U2. Now what is U2? This is U2. So initial distance was 40 centimeter. Now you moved it closer by 20 centimeter. So U2 must be equals to minus 20 centimeter. Okay. So how to do that? So people sometimes get confused with sign. So sign is common. So what you have to do? Minus 40 by 20 centimeter. This is the easier way. So minus 20 centimeter, right? So you apply the sign to overall thing. Don't apply sign and then add it. Okay, you apply the sign to all over thing, right? So now U2 is minus 20 centimeter. So you have to calculate V2. So V2 is basically 15 minus 15 into minus 20 divided by minus 20 minus 15. Similar process. So it will be 15 into 20 divided by minus 20 plus 15. So it will be 15 into 20 divided by 5. Okay, 5 4s are 20. So it will be 60 centimeter. Okay, so final object distance is 60 centimeter. So there will be a negative sign obviously. So what is the displacement? Displacement delta V is V2 minus V1, but both we are only taking the magnitude. Okay, we will not consider the sign for this. Sign is necessary when you are applying the mirror equation. If you are not applying sign in the mirror equation, thinking that okay, that because at the end we do not need the sign, so we can skip that while applying the mirror equation as well. No, you will get the wrong answer. Okay, you can try and check, you will get a wrong answer. 60 minus 24, so that will be 36 centimeter. So 36 centimeter is the answer for this question. Let's see. Yes, 36 centimeter. Now next question. An object is placed at a distance 0.3 meter from a convex lens of focal length 0.2 meter. Now it is about lens. Find the position and the nature of the image formed. Also find the distance through which the object should be moved to get an image of linear magnification -1. Now this part is easy. The last part is actually easy. We will see that. First we have to calculate that object is placed at a distance 0.3 meter from a convex lens of focal length 0.2 meter. Find the position. First we will find the position. So what is U here? U, as I said, is always negative, that is 0.3 minus 0.3. And for convex mirror or convex lens, focal length is always positive. Focal length is always positive. Okay, so U is minus 0.3 and F is 0.2. Okay, now let's apply the lens equation. 1 by V minus 1 by U equals to 1 by F, right? Don't confuse between lens and mirror equation. There is a plus sign here for mirror equation, there is a negative sign for lens equation, right? Now 1 by V, we are trying to find V, so this will be 1 by F plus 1 by U, or 1 by V equals to F into U plus F, or V equals to UF divided by U plus F. Okay, this is the simplification of the formula without doing too much difficulty. Now u is given by minus 0.3 and f is given by 0.2, u is again 0.3, f is 0.2, so it will be minus 0.3 into 0.2 divided by minus 0.3 plus 0.2, that means it will be minus 0.1. So minus minus cancels, right? You can even cancel one of the points here, you can remove one of the points here, so it will be 0.3 into 2, that is 0.6 meters. So the image distance is 0.6 meter. Now what is the nature of the image? Now as you can see that here the object distance is greater than that of the focal length, right, magnitude wise, because object distance is 0.3, image distance focal length is 0.2. that means as it is beyond the focus, the image has to be a real image, right? Also it is being proved by the v being positive for a lens. That means if this is the lens, object you keep it here, then u is negative because it is along the negative x-axis, right? And after the refraction, image is formed on the other side. Okay, that means image distance is positive. So because of that, we can say that image must be a real image. Must be a real image because v positive in this case. Okay, for a lens, if the v is positive, then definitely it's a real image. Okay, now because it's a real image, it will be an inverted image. Okay, so nature of the image is real and inverted. So nature is real and inverted. Now next, what? Also find the distance through which the object should be moved to get an image of linear magnification -1. To get a linear magnification of -1, which is only possible when you place the object at a distance 2f. Okay, when the object is placed at a distance 2f, the image is linear magnification is -1. Why? Because image is also formed exactly at 2f but inverted, right? To get, you have to write that to get an linear magnification of -1, we need to put the object at 2f. So what is 2f here? 2f distance is basically 2 times the focal length. Focal length is 0.2, that is 0.4. So in this case, u should be equals to 2f, that is 0.4 meter. So the displacement, say this is delta u dash, so the displacement will be equals to u dash minus u, that is 0.4 minus 0.3, that is 0.1 meter. So this is a easy part, right? So if you have answered this, you get 1 mark, and for the calculation etc you get 4 marks, right? Easy question. So 0.6 meter real, 0.1 meter, the object should be moved by a distance of 0.1 meter. Now this question is from year 2024. Okay, a small bulb point source is placed at the bottom of a tank containing water to a depth of 80 centimeter. So there is a tank, some water is there, and there is a tank, there is a lamp at the bottom of this tank. Okay, and depth is 80 centimeter. The depth is given as 80 centimeter. To solve such questions, the diagram is must. Okay, similar questions can only be solved when you are drawing using a diagram. Now what is the radius of the circular surface of water through which light emerges out? Refractive index of water is given as 1.33. So what is basically they are asking? If you put a bulb below a tank, water tank, okay, what will happen that the rays will go and they will refract, but after some time at the certain angle of incidence, okay, the ray will graze past the medium, and anything more than that they will come back to the first medium. So it will be a total internal reflection. Okay, so we have to find, we are not interested in this, we are only interested in this ray. Okay, and this will happen in all possible direction. So what will happen? This will happen in all possible direction for same angle of incidence, and you will get a circular shape here. Okay, so if you put it under the tank, you will get a circular surface on the top of the water. So you have to find the radius. So you have to find this radius. This is our target. This radius is our target. What is the radius? Right? So let me erase this line so that it is not confusing enough. Right? So we are trying to find this radius, and for that obviously you understood that what is this radius. This must be the normal. Okay, this angle is I. So if this angle is I, this angle will also be I, and from there we can find this R. But first we have to calculate based on the fact that this angle will be critical angle. That is very, very important. So when the ray is grazing past the medium, that means this is the, not the critical angle, this angle is 90 degrees. This angle is 90 degrees, and this can be considered to be critical angle, even though it is fine. Now, how to calculate critical angle? We know that from Snell's law, sin I is equal to mu sin R, right? Mu I is equal to n1 sin I is equal to, not write like this, n2 sin R. That will be easier. So here n1 is this medium, first medium, because light source is coming from here traveling in this direction. This is the second medium of air, that is n is equal to 1. So this is n1, this is n2. Okay, now we have to apply this here. So n1 is 1.33 sin theta c equals to n2 is 1 sin 90 degrees, right? Refractive angle at this position will be 90 degrees, angle of refraction, right? So now sin 90 is 1, so 1 into 1, that is 1. So sin theta c is basically 1 by 1.33. Okay, or theta c, you can calculate theta c. So this 1.33 will be, I think, 4 by 3. So it will be 3 by 4. Theta, you can calculate, the value of theta will be theta, we do not need even the theta. With sin theta c is fine. Okay, sin theta c is sufficient to calculate this. So it will be 3 by 4. Right? Now, what we can do from this? So if this angle is theta c, this angle will also be theta c. Okay, two rays parallel, they are intersecting. If this angle is, say, x, this angle will also be x. Right? Alternate angles. Now, we will apply some knowledge of trigonometry over here. How to do that? If this is approximated value, not exact value. Now, this is the height, that is 80, given to us. We are trying to find this R. Okay, we are trying to find this R. Now, how to do that? This will be theta c. So tan theta c, you can calculate the value of theta c from here, whatever the value you can calculate. So tan theta c is given by base perpendicular by base, right? So tan theta c will be perpendicular by base. So perpendicular, this is the angle known. For this angle known, this is the perpendicular side, this is the base side, right? Adjacent sides are base, opposite sides are perpendicular, right? So this is R. So R is basically 80 tan theta c. If you calculate, if you put the value of theta c, it will come out to be 91 centimeter. Okay, so you can calculate theta c and check that answer. Okay, this is exactly the same question came in your previous year, just previous year question. Okay, there is a less chance of repeating this question, but still in case you may have some doubts, I have solved this question as well. Now question number 19. Two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Now this question is very favorite among some district level question paper setters, and they ask it almost every year in your pre-board exam. Okay, so I know your pre-board exam is coming, so this is a very important question for pre-board exam. Two lenses of focal length 0.2 meter, and also important for board exam, obviously, that's why you are solving it. Two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination. Two lenses of focal length, say f1 and f2, when they are left in contact, the combined focal length is given by, you can treat them as like resistances in parallel. Okay, or F equals to F1 F2 divided by F1 plus F2. Okay, this is the formula you should remember, right? Now two focal lengths are given 0.2 meters and 0.3 meters kept in contact. Find the focal length of the combination. So basically what you have to do, 0.2 0.3 divided by 0.2 plus 0.3, easy. So it will be 0.06 divided by 0.5. So multiply 2 both sides. If you multiply 2 here, multiply 2 here, what you will get? 0.12 divided by 1. Okay, 0.5, if there is a 0.5 in the denominator, this is the way to solve. So it will be 0.12 meter. This is the focal length of the combination. Now what else? Calculate the powers of two lens combination. Calculate the power of the lens combination. Sometimes they ask you to calculate the power of individual lenses and that of the combination. Individual lenses P1 is 1 by 0.2. Everything is meter, so you don't need to convert it. Okay, don't do it by 100 by 0.2 because 100 applies only when there is centimeter. This will be simply 1 by 0.2, that is 10 by 2, that is 5D plus 5D. P2 is basically 1 by 0.3, that is 10 by 3, that is plus 3.33 diopter. Okay, and P combined is equals to 1 by 0.12. So power is basically 1 by focal length. You remember this formula when F is in meters, right? So it will be 100 divided by 12. So why I am doing this? I am just trying to remove this decimal. So two decimals were here, so I have added 100 in the numerator. So if you have still confused why I have written it like that, so there was one denominator, one decimal, so I just replaced it. Okay, so many students I know will have difficulty because they are not super familiar with solving numericals. So 6, 50, 3, 25, so it will be approximately 8.33 diopter. Diopter is the unit of power, right? So simple question, easy question, not super hard but still very common. Now next question, a prism of angle 60 degrees produces an angle of minimum deviation 40 degrees. What is the refractive index? Calculate the angle of incidence. Again you have to use the calculator to calculate the exact value because this kind of problems are slightly mathematically important. So what is the angle of prism. Angle of prism A is 60 degree. They might give you that equilateral prism. Equilateral prism means also angle of prism is 60 degree, right? So the angle of minimum deviation is 40 degrees. Okay, so we know that what is the refractive index. Refractive index is given by sine A plus delta m by 2 divided by sine A by 2, right? So this is the formula. So just put the values. Sine 60 plus 40 by 2 divided by sine 60 by 2, so it will be sine 50 divided by sine 30. Now I remember this answer, it will be 1.53. okay, some 1.53 will be the refractive index, but you have to use the calculator to find it. Now what is the refractive index? Calculate the angle of incidence. That is important. How to calculate angle of incidence? Okay, angle of incidence is basically this angle. Angle of incidence is A plus delta m by 2, that is 60 plus 40 by 2, that is 50 degrees. Okay, so this is the answer for this question. Okay, no, this is 50 degrees. 10 degrees is a different question. This will be 50 degrees. Okay, so this is the answer for this question. I hope you enjoyed today's session, and if you have any doubt you can mention that in the comment below. Also, if any of your brothers, sisters or cousins or neighbors, anyone who is currently studying in class 10th, ask them to follow our other channel, Diksha Vedantu Foundation channel, where we are currently only working on class 10th level content. So if they are preparing for their board, definitely our channel is going to help you, like our present channel is helping you. So ask them to join our channel, share it with them. The link will be given in the description. So I'll be back with a new video, new series soon, and till then, bye.